Hello. Am I live? I've got no idea. It says I'm live. Is this good? Can you let me know? Is this working? Are we good? Hello, 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 hello everyone. It says I've been live for 20 seconds, but I have no idea what's going on. I think we're good. I think we're good. Okay, well I did a poll and it said, should I go fast, get through more questions, or should I go slow to let you guys have a go yourself? And 2/3 of you have said fast. So I'm going to go fast. Well, yeah. So I've got 8 questions planned. They are obviously 4 mechanics, 4 stats. I think they're quite tricky, but what I'm going to do is I'm going to start with the easiest ones first, and then build up to the harder ones. Okay, and I will try and keep on top of the chat as well. Right, should we get into it then? Let's do it. Okay, we've got variable acceleration, and we have the formula for velocity, and it is in terms of I and j, so it's 2-dimensional. So what we're going to need to do is either differentiate or integrate that. Now it says here that we need to find the magnitude of the force. So what are you saying, guys? Are we differentiating or are we integrating? Are we differentiating or integrating? Differentiate, yes. One guy's in on there. Okay, we're differentiating because force is equal to mass times by acceleration. And if we differentiate, we get the acceleration, which we can then link to the force. Bish, bash, bosh. So the acceleration is dv by dt. Someone's put in there PVA, love that. Yes, Patrick Van Aardhol. And that is going to give me 2t minus 3 in the I. And I'm going to want to bracket that up so I know that's my I. And then this is just going to give me minus 12, and that is in the j. Okay, lovely. Next, let's introduce that classic Newton second equation, and that is F equals ma. And we know that the mass is 0.5, so we are going to be putting that into this formula here. And the acceleration is what we've just proved over there. So that is looking nice. Okay, tell me the magnitude of the force. I've got the force. Once I times it through by 0.5, how do I find the magnitude of the force? What am I doing there? So let's times this through by 0.5. How do I find the magnitude of the force? Up the palace. Yes, let's go Crystal Palace. How long will this live session be? I don't know. I don't know. Maybe an hour. Maybe a little bit longer. Who knows? Pythagoras, exactly. That's exactly what we're going to do. So 6.5 is equal to the square root of the square of the components summed together. So we're going to do this. Lovely. Okay, this is all going to come out nicely. When I square both sides, I'm going to get this. And see, this is where I'm probably going to speed up and go fast because, like, you know, we all know how to solve equations, don't we? Or at least we should do. So then what I'm going to do is I'm going to expand out those brackets. That's going to give me t squared minus 3t plus 9 over 4 plus 36. Then we're going to set it equal to 0. Lovely. That gives me, carry over, minus 4, I think. And then that is t minus 4, t plus 1, and then we are good. That's got to be t is equal to 4 because t can't be negative. We good with that, guys? Is that all good? That is like a nice little standard question to get us started. Hopefully that's all good. Hopefully that's all good. Is this primary school SATs? Is that too easy? Fair play. Okay, right, let's move on to the next question then. So we've got normal. I'm going to go mechanics and then I'm going to go statistics. Why not? Let's just mix it up. Do one of each as we go along. Okay, so this is a classic question where you don't know the mean and you don't know the standard deviation. So you could write that x is normally distributed mu and sigma squared, like that. So what are we going to do if you don't know the mean and you don't know the standard deviation, guys? What we're going to do? Solve simultaneously. Standardize. Yes, the Z distribution, exactly. Okay, first thing we're going to do though, because if it's tricky, we've got to draw a picky, exactly. So right in there, we've got this to the left is 15%, and that is under 74. And then we've got to the right 20%, and that is over 115. Okay, right, I've just realised I need to use my calculator for this. So I need to move this over here. I'm going to whip out the old class whiz. There you are. Beautiful. Okay. Into the distribution we go. We hit the inverse normal, and we want an area to the left of 15, and we want the standardized normal, so that is sigma 1 mu 0, and we get our first Z value. What's the formula that links the Z values to the X values? It's not given in your formula book, so you do need to know this. What is that formula? What is that formula? Z equals X minus mu over sigma. Love it, exactly. So we have the X value for that one, which was 74, minus mu over sigma, like so. And that's all we could do with that because we've only got two unknowns there, so we need more information. And we're going to go back to our normal distribution. Now, what area am I going to put in for the 20% to the right? What area am I going to put in for the 20% to the right? Bosh, 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 bosh. Yeah, 0.8, exactly. Because if it's 20 to the right, then it means it's 80 to the left, and the calculator only goes to the left if you've got the old class whiz. If you're rocking a CG50, then you're just absolutely flexing. You can go both ways. Okay, so that is equal to that, and that is 115 minus mu over sigma. Okay, from here we can rearrange. So I can multiply through by sigma and then add mu on afterwards, like so. And over here we can do exactly the same, and then add mu on afterwards, and we get 115. Lovely. Okay, from here we could just solve simultaneously. I'm not going to waste your time solving simultaneous equations literally the night before your final A-level. So when you do it, you get this, and it does say to the nearest minute, so let's round that up to 97. And when you do that, you get 21.8, and then let's round that up to the nearest minute, 22. Okay, who's looking for we've got a hypothesis test next. Now there is something so important. Oh yeah, that's negative. No, I got that as negative. No, that should be positive. We know the Z values. Okay, if it's on this side, the Z values to the left are negative, the Z values to the right are positive. Okay, right, we're doing normal hypothesis. There is something so important that you have to remember for the normal hypothesis. So important. If you don't remember it, you're just going to have to, you can just basically chucking away marks. Okay, let me just get rid of this working. Okay, oh, you use 0.2 instead of 0.8, that's why you got a negative, yes. X bar, Bosh, yes, Yasin, that is correct. X bar is the distribution that we have to use. And what is the sample normal distribution? Sigma squared over n for the variance. Yes, absolutely. So 97 is the mu that we're going to use, because that's the population mean that we just calculated from the last part. This was 97 and this was 22. Now the variance, if you write it as the variance, it will be 22 squared over n, which in this case is the sample 10. But what I like to do, because I think I'm less likely to make mistakes if I do this, is I write 22 over the square root of 10. That's the standard deviation, and then we square that, okay, when we write it in our distribution, you know, just like that. But the only thing you're going to be working with is that the standard deviation that you're going to use for this distribution is 22 over the square root of 10. Okay, right, we've got a hypothesis test to set up, haven't we? So we say H0 mu is equal to the population mean, which is 97, as we found out before. We then say H1 is mu is greater than 97. Okay, let me answer a few questions just so we set this up. Why did I say greater than? I said because the person believes the mu is higher. So that's why we've got the greater than there. When do you use the X bar? Only when you are doing normal hypothesis testing. Okay, when you are doing normal hypothesis testing for the mean, this is when you use the X bar distribution. If it's not a normal hypothesis test for the mean, you don't use it. You just use the standard standard deviation. You don't do anything to like dividing it by the sample space, sample size. Okay, right, we've got that set up. Now what we need to do is we need to test the test statistic. So the information that we got given was that the mean time was 108 minutes. So we need to find the probability that X bar is greater than 108 minutes. Now remember, whenever you're doing a normal hypothesis testing, whatever way this sign is pointing, that's the way that you're going to have to do the probability that you find, like that. Okay, lovely. Right, so let's go then. Let's go into distribution. Let's go into normal CD. And we want the lower to be 108 and the upper, massive number. Octazuka, I'd love to sit the exam for you, but unfortunately that would be illegal. Okay, 22 over the square root of 10. And then the mu is 97. You see what I did there, guys? So important that you divide by the square root of the sample size. Okay, great, we get the probability. Right, so now you know the probability. What you're doing, you're rejecting H0 or you're accepting H0? Hit it up in the chat. What are you doing? Because this is actually greater than our significance level. That is greater than our significance level, so what are we doing? Accept, accept, accept. Got a few rejects in there. But this is definitely, we're accepting H0. Okay? We're saying that this is likely to occur. So if something's likely to occur with the old mean, there's no reason to expect or that the mean has changed at all. So we say, I'm not going to bother writing it down to save time, but we say not enough evidence to suggest mu has increased. Okay, we do not reject H0, we accept H0. All good with that, guys? All good? Okay, right, love it, love it. We're going to crack on so I can get through as many questions as possible. Can you do the critical region method? I mean, you could do, but if you're given, unless they ask you to, I wouldn't bother. Why? It's just more stressful, I think. Okay, are you watching the Euros? I've only watched one game so far just because I've been busy grinding YouTube and trying to get as much content out for you guys. I watched the England game. But as soon as I click end stream, I'm going to be watching every single game. Okay, right, we've got a relatively easy one here. This is position vectors. Okay, position vectors. And what the first thing that jumps out to me is that it says the acceleration of the boat is constant. So what does that mean that we are going to be doing if it says the acceleration of the boat is constant? How is that different from the last question that we did, mechanics wise? And what type of equations does that mean that we are going to be using? Suva! Absolutely, yes. Absolutely love a Suva equation. I cannot tell you how much I love a Suva equation. Okay, so whenever I see Suvat, I write Suvat down the side of my page, just like this. And then I write equals, 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 and I'm just going to fill in as much as I know. And the interesting point is what's happening at t equals 15, because that is the bit, that's the point where we know the most information. So t equals 15, we know the velocity at that particular point is 10.5 I minus 0.9 j. And we know the initial velocity, what does this say? Moving north with a speed of 0.6. So what's the initial velocity then, guys? What's the initial velocity? I think the initial velocity will be, it's moving north, so we need a vector in there. It's got to be a vector. It's 0.6 j, because j is north. J is going up. Yes. Lovely, lovely, lovely. Are you going to post the live? I don't know. I've never done a live session before. Does this not just like post automatically once it's finished? I don't know. Okay, anyway, what do we need to do next? A. We need to find A. We've got enough information now, so we can tell S to do one. Get out, do one. And then we can use the formula which has no S. What's the formula of no S? A little burrow. Thanks. What's the formula of no S? Yes, this will post on your channel automatically. Brilliant. There it is. V is equal to U plus AT. It's the easiest Suvat to use, 100%. So 0.5 J. Welcome to support Mr. Asprey. I don't know what that means, but Ricardo, you're a legend. Minus 0.9 J is equal to U, which is 0.6 J. Oh, that means you're a member. Oh my God, I've got members. Okay, so A we don't know, but 15 is T. Okay, let's just solve this then. So let's move the 0.6J over to the other side. And that will give me this. And then let's just divide through by 15 and we get exactly what they want. Okay, that's nice, that's nice. Right, on to the next one. Find R. R is position, which is the same as displacement. It's the distance travelled away from the origin. So, man sent you £3 and got aired. No! I'm sorry. I didn't see that. Yeah, but thank you. Whoever did that, that's very kind of you. Very kind of you. Love that. Oh, I see, because he's a member. Yeah, £3. Thank you very much, Ricardo. Nice. Nice. Right, so S. What is S? Well, we're going to use the big daddy, aren't we? The big dog. S equals UT plus a half AT squared. The absolute beast of a Suvat equation. And and we're going to just plug in. We're going to plug in. We're going to get 0.6j is the u plus a half of the a. So what's half of the a? That's 0.35i minus 0.05j. And that is multiplied by t squared. Yes! Another member, Riley Kean. Yes! Love that. And AZ Studios, that's very kind of you. You get 1 membership. I am such a noob on streams, honestly, guys. I'm so sorry. I'm such a noob. But yes, S equals ut plus a half at squared is the big daddy CVAT equation, 100%. It's the most useful one. Okay, so what we're doing next. Aha, well, this is why I picked this question. Because people get absolutely shook when it comes to a boat being in a particular bearing position. Okay? Northeast of the origin means that this object, or in fact, you tell me, what does it mean, northeast of the origin? Yes, thank you, Ollie Hope. And Sam Freeland. Love that, thank you very much. What does it mean if it's north of the origin? I equals j. Yes, I equals j, that's true, but what? Ri, is it the position or is it the velocity that equals which are the same? I sent you £15, bro. No, don't do that. That is no need for that, Val. But thank you if you did. That's incredible. But no, mate, that's very kind. Anyone who I don't know what's going on. But anyway, that is very kind of everyone. Ri is equal to Rj. The position vector needs to be the same. Okay, great. So that means that 0.6 is the j minus 0.05. The j is 0.6t minus 0.05 t squared. Okay, and that equals the I, which is 0.35 t squared. Okay, do you see what I did there, guys? I looked at the j, which is these two combined, and then I set that equal to the I, because that is when we are in a position which is northeasterly. Okay, we can solve that. I'm not going to bother solving it. I'm just going to tell you what the answer is. It's 3/2. Bosh. Okay, now the next one. Part D. Tell me, when it's moving in the northeasterly direction, what have we got to do now? It's moving in the northeasterly direction this time. So good. That means that VI is equal to VJ. Okay? The last time it was just on a northeast line. It was in a position northeast. This time it is moving northeast. It's completely different. So this time we need to set the velocity equation equal to. So the velocity equation, we don't quite have it yet, do we? But it's just u plus at, which is 0.6j plus, what was the acceleration? Where is it? There it is, 0.7i minus 0.1j_t. Okay, great. So what we do is we look at the j's, which are these two. So that is 0.6 minus 0.1t, and that is equal to the i's, which is just this, but don't forget times it by t as well. We can solve that and we get 3/4. Bosh. Is that good? Are we good with that, guys? So I picked that one because I know people get so, vexed at not knowing which components to set equal to. Okay. Right, let's move on, shall we? Let's move on. Okay, right, back to the normal distribution. Or is it? No, but this is binomial distribution to start with, but then it's a normal approximation. And again, I picked this one because I know that people absolutely get messed up with their continuity corrections. Okay. Should we get started? Yes, let's do this. Let's get the calculator up. And here it says that we know that the probability is 0.35. And he believes that it will increase the probability of hitting the target. He gets a new bow. And then let X be defined as the number of successful hits. Assume that they're independent. Determine a critical region based on 20 shots with the new bow. And the significance level needs to be as close to 1% as possible. Okay, that's another thing they do to try and throw you guys. They will say close to 1% rather than just less than. Okay, so we start by setting up the distribution. This is a binomial distribution because you either hit the target or you don't. So two options. They are independent of one another and there's a certain number of trials, in this case 20, and the probability is fixed at 0.35. So we write that H0 is equal to the population probability, and then we write P is greater than 0.35. Now when you say that P is greater than, you know you're in a bit of trouble here, because it means you've got to work out the upper tail, which is more difficult than the lower tail. If you've got the Casio class whiz, if you've got the C50, it's absolute child's play. Okay, so how many would we expect to get out of this distribution? What would be our expectation? How many would you think you would get, roughly? How many do you think you would get? One or two? 5? We would get 7. 7 because it would be 20 times 0.35, so we'd expect to get 7. So we're going to have to go higher than 7. So let's start off at maybe x is greater than or equal to 10. So we go into our distribution. This time we go into binomial CD, variable, and we go x is 11, or in fact no, we don't, because to get greater than 11 we need to do 1 minus greater than 10, less than 10, 1 minus less than 10. So we'll go for 10, we'll go with n is equal to 20 and p is 0.35. And we get, well that's not enough, is it? Because if I do 1 minus 0.948 blah blah blah, that's just going to give me 0.0532. So about 5%. So that's no good. So I go back and I go up one more. So this will be me checking the probability that x is greater than or equal to 12. Because I'll find the probability of less than or equal to 11 and I'll do 1 minus it. Okay, hit the button. Okay, is that good? Well, I'm still not quite sure yet, but what I need to do is I'll need to subtract that, and that gives me 0.0196. Okay, so one more just to double check, because that one is still above 1%. So we do this one, and we go back and we go 12, and it really is just trial and error, guys. So that's 1 minus 0.9940, and that gives me a probability of 0.006015. Okay, so this one is closer to 1%. That's about 0.6%. And this one is just under 2%. Oh, thank you very much, Hugh Janus. Yes, support Mr. Asprey. Let's go. Thank you. Okay, so yes, the critical region is that x is greater than or equal to 13. That's the critical region. Bosh. Okay. Are we good? All I can hear is lots of ha-has and no. What, have I made a mistake? No. No, that's all good, man. I'm sure that's all good. Yeah. Yeah. Someone say yes, sir, you're all good. Oh, the member's name. Huge Hannes. You guys. Oh, very good. Very good. You got me. Absolutely got me. Absolutely. Hook, line and sinker. Okay. Yeah, no, there's no need to be messing. It's not like we've got an A-level tomorrow, guys. Right. Let's go. Now we've got to do the normal approximation. The normal approximation. Okay, so we have a binomial distribution this time. And this time what they're doing is 150 arrows. So 150 is going to be our number of trials, yeah. And the probability is still 0.35. And now, how do we find the mean and the variance for the normal distribution approximation? What are they, guys? What are the normal? What's the mean and the variance? NP. Yes, exactly. Mu is equal to NP, which is 150 times 0.35, which is 52.5. And the variance, NP times by 1 minus P. So I've got to take that NP and I've got to times it by 1 minus P, which is 0.65. And I get 34.125. Okay, so that means I can set up my normal approximation distribution, and it has a mean of 52.5 and it has a standard deviation of, a variance of 34.15. Now, I need, because it's a hypothesis test, and we are testing the upper tail because it says that, well, we did it in the last time, didn't we? We said that H0, P was equal to 0.35, and he thinks that the thing has got better, so P is greater than 0.35. What is the probability that I need to find? Can you do that continuity correction? Can you do it, guys? So, what's your snap? As if, no, I don't have Snapchat. What is that probability that we need to find? Because he hits 59 arrows. So I need the probability that X is greater than or equal to 59. But that's approximately, using the approximation, that W is, oh, what have we got? We got a lot here. We got 58.5, we got 59.5. We got a lot of different answers here. Well, if I want 59 or more, then the smallest I could possibly go is 58.5, because that would round up to 59, which would be acceptable. Okay? If you're going greater than, then you need to find the lower bound. If you're going less than, you need to find the upper bound. Okay, so we can find that probability and we get 0.1522. In fact, let's just do it on our calculator just to make sure that we type in the right thing. So we go to normal CD. and we go to, we want the lower to be 58.5 and upper to be as large as possible. So that's a huge number there. Whoops. And we need the standard deviation to be the square root of 34.125. And we need the mean to be 52.5. Okay, beautiful. There it is. There's that probability. Now that's greater than 5%. So what are we saying, guys? What are we saying? What are we saying? We need the J. Cole, Mr. Asprey collab. Can someone explain continuity correction? Yeah, absolutely. Okay, so that means that we accept H0, yeah. We do not reject H0, and that means that there's insufficient evidence to suggest a new bow increases the probability. Okay, right, the best way I can explain continuity correction, yeah, is that you have, in the binomial, you have all these probabilities. So you had like 57, 58, 59, 60, 61, for example. Okay, and then you wanted greater than 59. So you wanted 59 or more. So you want all of these ones. But the problem is the normal distribution can take any value at all. It looks like that. So we need to find the smallest value possible such that it rounds to 59. So I can use all of this area here because normal distribution is all about area as opposed to just adding up the sticks like that. Okay. Right, let us move on then. What have we got going on next? So I've got projectiles question, I've got a ladders question, I've got a dynamics question on a slope. What are we going to? Are we going straight to ladders or are we going to projectiles? In fact, I could do a poll, can't I? Yeah. Start poll? No, I don't know how to do that. End poll. End that poll. Start new poll. Start poll. Ladders or projectiles? Let's see what you're going. Ask question. Next question. Bosh. Start poll. Go. Poll has been started. Hit it up, guys. Bosh. Bosh. 500 votes. We've got 73 for ladders. Okay, right. This is a beast ladders question as well. In the fact that it challenges your understanding of friction, which I know people have been getting vexed about, because I've been getting loads of comments about friction and which way does it go. Okay, I thought, okay, let's go. I thought if the p-value was smaller, we reject H0. If the p-value is greater, yeah, if the p-value is smaller, then we do reject H0, yes, but the p-value there was large, it was 15%. Okay, we've got the normal coming out like that. Got to draw on all your forces, guys. Draw them on nice as well. Okay, it should be like a Picasso. It should be beautiful. Okay, what else we got going on here? We have got the weight, which is just W. So that comes out like this, and I'm just going to call that W, like that, because we don't need to times it by G, because that's not the mass, this is the weight, so only times it by G if we have the mass. Okay, what else do we have? We have a builder, weighs 7W, stands on top of the ladder. So you're going to come down like this, that's going to be 7W. And we also have a frictional force because it says that it's on a rough horizontal ground. Okay, so the frictional force is going to be acting this way, keeping it in the correct position, like that. Okay, and do we have any other forces? No. So I think what we need to do is we need to now take our component. Oh no, we've got one more force. We do have another force. We got another dude. Well, I say dude, I don't know, could be a woman. Builder's assistant applies a horizontal force of magnitude P to the ladder. Okay, so someone is pushing this way, like that. And let's call that P. In fact, let me give that a different colour. Like so. Okay, that's beautiful, lovely. Okay, we need to take components because these questions are so formulaic. I'm not even going to bother reading the question pretty much. I know exactly what I'm going to do. I'm going to do moments at A. Because moments at A is going to completely wipe out P, F, and R, which is actually going to give us an opportunity to find out some of these forces. Okay. So here we go. We are going to have the component force of the weight. It's going to come out like this. And that angle in there is always the same as the slope. That's alpha. So what is the component of the weight acting perpendicularly to the ladder? Which one is that? Is that cos or sine? Excuse me, let me know. Is that cos or sine? The one that sticks out like that, the one I've just drawn? Perfect, cos alpha. In fact, someone says, wouldn't friction oppose P? To be honest, I don't actually know which way friction is going. I don't actually know yet. And if you don't know, then that's fine. You can still put it on going in a particular direction. It just means that you might calculate it and it'd be negative, and then you realise actually it's going the other way. But anyway, it doesn't matter because we're doing moments at A, so the frictional force is going to get completely wiped out. And yes, that one is W cos alpha. Okay, what about this one? Coming out there, the component of the builder's weight. What's that one going to be? Instead of rough horizontal ground, you could say that the ground is grippy. I guess you could. I don't know why you would say that, but anyway. Daddy Asprey, I'm your son. Do you remember me? Don't quite. No, my two sons are upstairs sleeping, so I don't think that's the case. Okay, that is 7W cos alpha. Yes, exactly. That is 7W cos alpha. Now, okay, guys, what about the component perpendicularly to the normal reaction? Which one is this? Which one is that? Which one is that one? The one, it's 7 p.m. It is 7 p.m. 7 p.m. bedtime is criminal. not for an 18-month baby. Sine. It is sine. Yes, it is. Now, why is it sine? Well, you can see this angle in here is alpha. So by Z angles, that angle is alpha. If I were to complete the component triangle like that, then this angle in here is also alpha by Z angles, and alpha is pointing to the component we want, which means alpha is opposite that component, which means that is sine. So that is n sine alpha right there. Okay, well, we don't need those ones actually, so I can get rid of them. We don't need that. But yes, we have now established that is n sine alpha. So let's do those moments. We go along the ladder like so. The first force we hit is a distance away, and it is W cos alpha, and then we keep going. The next one we hit, well, there's 2 right there, aren't there? So 2a 7w. And those 2 are acting clockwise. So we'll put them on the same side of the equation. And that one is cos alpha as well. And then that's equal to the one going in the opposite direction. And that is 2 away again. Don't forget to put the distance in. And that is n sine alpha. Okay. Good stuff. Right, next we've got to draw our tan diagram, our triangle. We've got alpha in here, and we have 5 is the opposite, 2 is the adjacent, so not particularly a nice one, but that is going to give us root 29. So that's going to tell me that sine alpha is equal to 5 over root 29, and cos alpha is going to equal 2 over root 29. Okay, lovely. So let's tidy this up then. This is going to give me, in fact, we could do a bit of cancelling before we tidy. A's can go. Nice. So w cos alpha is 2 over root 29 w plus, this is 14 w times by cos alpha, which again is 2 over root 29, and that's equal to 2n sine alpha is 5 over root 29. Okay, good. We can get rid of root 29. Okay, I'm just going for it now, guys. I'm not checking the chat. I'm just going to go for this, finish this one off. That gives me 28w, and that's equal to 10n. So we get 30w is equal to 10n. So that gives me 3w is equal to n, which is perfect. Yes, love that. Yes, and well, thank you, Riley Keegan. Yes, love that. It's very kind of you. Okay, I'm not sure. I've got. Is there a reaction force coming off the builder? No. We're only looking at the ladder. Okay, so we're only caring about what forces are acting on the ladder. Okay, good. So that's that done. And now here comes the tricky question, and that is that it says that friction can change. It says find in terms of W the range of possible values for P for which the ladder remains in equilibrium. Okay, so that means that we can have a range of different values for the frictional force. And that is all dependent on how hard this builder's assistant is pushing into the ladder. Because they can push really hard, which means it will start to slip forward, or they can push really slowly, which means it will start to slip backwards. And both scenarios will have different directions for friction. Okay? So let's imagine that P is at its maximum. Let's imagine that max P. The guy is pushing as hard as he can and it's just about to slip forward. What direction would friction be acting if P is pushing as hard as it can and it's just about to slip forward? Let me know which way is friction going to be acting if P is at its absolute max and it's just about to slip forward. Okay, perfect. Backwards is correct. Yes, or to the left. Okay, so in that scenario, we're going to have that the friction is going to act against P, like that. So if we do components, then, not components, sorry. If we do resolve forces horizontally, then we're going to have P going to the right, minus F and we're going to have minus n as well equals 0. Okay, because we're going to have p, whoops, we're going to have p going to the right, and n and f going to the left. And it's still going to be in equilibrium. And what else do we need to do? We need to find r, in fact, don't we? R is important. R, again, we could do that by resolving vertically. So R is equal to, what have we got going down? We've got W and 7W, that's it. That's all we've got going down. So R is equal to 8W. Right, guys, a lot of people just spamming the chat. I'm not sure what we're doing here. So it's all over my. I don't know what you're doing. Come on, guys, we're here to learn, yeah. So we've got R going up. We've got it's 8W. Okay, great. So what do we know about friction? Friction is equal to mu R. And we have mu is a quarter from the question. We can see that in here. And that is times by R, which is equal to a quarter times by 8W, which is equal to 2W. Okay, good. All right, I've got a question there. Why is P at its max? Well, we're trying to find the range of possible values for P. No, for F, sorry. Oh no, for P. We're trying to find the range of possible values for P. Yes, we are. So the maximum it could be is when it's just about to slip forward. And we're going to find out then what's going to happen with the minimum. So I'm going to get P minus F, we just worked out, is 2W. And N, we worked out here in the question before is 3W. So that means in this scenario, P is equal to 5W. Okay, now we're going to try what happens when P is at its minimum. So what happens when the builder's assistant kind of doesn't push very hard at all? It's just about to slip backwards, which will be terrible for the builder. And which way is friction going to be acting in this scenario? Which way is it going to be acting in this scenario, guys? Oh yes, easy mode exams. To the right, yes, to the right, love that. Yes, it's going to be going to the right, because it's going to try as hard as it can to keep it from slipping backwards. Okay, so if it's going to the right, then our new equation of resolving horizontally is going to be P plus F. It's going to be going in the same direction as P, and that will equal N, or we could do minus N equals 0, same thing. Okay, so that's P plus 2W minus 3W equals 0. So in this scenario, P is equal to W. So the range is that W, what's it? It's between 5W and 1W, like that. Okay. Right, is that good, guys? Yes, P is between 5W and 1W. All because that critical understanding that friction opposes the motion and friction will act in the direction that it is needed in. Okay, so it can swap round if we reduce or increase other forces. So important to know that, guys. Right. I've got a probability question or a projectiles question. Let's vote. Let's vote. Or I've got a discrete random variable question. Okay, so let's go for next question. Next Q, we have discrete random variable, which is actually super difficult. We have probability, or we have projectiles. Yeah, let's go. Vote it up. What we go for? Oh my gosh, discrete random variables. Okay, this is an absolute beast question as well. It's absolutely nasty. Okay, it looks so simple. This is a Madas question, and yeah, it's tough. It's absolutely tough. And the reason why, I picked this one is because, sorry, I've just got to stop this guy from spamming. Put user in timeout. That will do. Okay, nice. Right. We've got, so the 2023, the discrete random variable question was horrendous. I'm sure you guys have already seen it. It's absolutely horrendous. Okay, so what on earth does this mean? Well, this tells us, almost like in a pure recursive sequence, what our values are for the probability. Okay, so let's start off. And also, this means that R is going to go on ... forever. Okay, forever. Yes, Breezy, love that. Thank you so much for becoming a member. That's brilliant. Okay, so what we always do with something like this, we just start. R equals 1. What's going on? R equals 1 tells us the probability that X is equal to 2 is equal to 2/3 of the probability that X is equal to R, which is 1. Okay? Seems about right. Yes, thanks for the help, sir. No problem. Appreciate it. Appreciate it. R is equal to 2. We get the probability of X is equal to 3 is equal to 2/3 of the probability that X is equal to 2. So what type of sequence is this forming, guys? What type of sequence is this forming? What type of sequence is this forming? This is a proper hard question as well, guys. Proper hard. It's forming, we've got some people saying arithmetic, some people saying geometric. It is a geometric series. Yes, absolutely. It's a geometric series. Absolutely. So what you're going to want to do with a question like this is you're going to want to put your probabilities into a table. Okay, so let's imagine when we have X here, and what is the probability? Okay, if I just say, let's just say for argument's sake, that this one, the probability that X equals 1 is K. Then what's the probability that X equals 2? What am I going to put in the next column? What's the probability that X equals 2? How is it geometric? Because every time to get the next probability, we have to multiply the one before it by 2/3. So that's why it's geometric. Yes, lovely. It's going to be 2/3 K. Okay, we're going to times by 2/3 to get the next one. Lovely. Okay, and then the one after that, what's that going to be? Can you not do sum to infinity? Absolutely, that is where this is going. That is where this is going. It says here, ads will run shortly for some viewers. No, skip that. No ads today, guys. Okay, this is 4, yes, 4/9K. Perfect. Love that. And it's just going to keep going on like this. So the next one will be 8/27K, because you're timesing by 2/3. The next one is going to be timesing by 2/3, 16/81K. And that's going to go on forever and ever and ever. So what are we going to do? What are we going to do? We know that all those probabilities are going to go on forever and ever and ever. And what do we know about discrete random variables? What do we know about the sum of the probabilities? Why can't you sub in r equals 0? Because it tells you that r has to be between 1 and then going on and on and on like that. It's going to be adding to 1, exactly. So if we add up all of these probabilities, all of them have got a multiple of k. So it's 1 plus 2/3 plus 4/9 plus 8/27. Imagine if this came up tomorrow, guys. How sick would that be? You know they're going to chuck a little bit of pure in at you. ... is equal to 1. Okay, because when we add up all those probabilities, it equals to 1. And then we just need to do a sum to infinity for this sum of numbers. So sum to infinity is a... No, it's not. What is it? I always forget this one. It's 1 over a minus r. A is the first term, which is 1. And the ratio is 2/3. So this just gives you, calculating, 3. So we know now that 3k is equal to 1. Because all of that yellow, infinite sum, is equal to 3. So k is equal to 1/3. Okay. Is it a over 1 minus r? It is, isn't it? Oh my god, I always get this wrong. Why? Why am I such? Why do I always get the sum to infinity? I even said it when I was doing it. And luckily, that actually doesn't make a difference because a is 1. And that's probably why I did it. Sorry, guys. It's in your formula book, no? It is a over 1 minus r. What am I doing? Okay. Never fear. That's one of those mistakes you can make in an exam and actually get away with it. Okay, I mean, you can't make that mistake. Don't make that mistake in the exam. I'm just saying in that particular scenario, I would have gotten away with it. Anyway, we need to find now, to finish this question, the probability that x is between... yes, thank you very much for that gifted membership. Appreciate it. It's between 2 and 4. So which ones is that going to be? It's going to be this one, and this one. So adding them up, we're going to get 2/3 of k and 4/9 of k and 8/27 of k. We know k is 1/3. We can add these all up. I don't actually know what it's going to give me, but this is all just calculation now, which is all good. And that gives me a total of 38/81. Okay, right, that was a toughie, eh? That was a toughie. It's a tricky question. What can I say? It's a tricky question. And that's the title of the stream. Tricky questions. Okay, how long is this going to be? I reckon I'm just going to do one more question, I think. Because I've still got left... I've got a dynamics, and I've got a probability, and a projectiles. Yeah, let's just figure out where we're going next. Okay, I'll show you the questions, in fact. Projectiles we could do. Probability we could do. Or dynamics on a thing like that. So projectiles, probability, or dynamics. Or we could do a hard normal question. But that's like a Madas one, like a challenge one. Okay, let me put the poll up. Start poll. Next question. We've got projectiles. Projectiles. We've got probability. Those Venn diagrams ones, and we've got dynamics. In fact, I think probably these are the two we're going to do actually, because the other two aren't as good. I think we should just go with these ones. Either probability or projectiles. Or maybe just do both. Should I just do both? I don't know. If people are staying and they want to learn, then why not? I don't mind. Oh damn, it's 50-50. Okay, I've got to do both then, haven't I? I've got to do both. Yeah, I've got to do both. Okay, yeah. It's 50-50. I've got to do both. And then I think I'll say goodbye. Okay, projectiles. We'll start with projectiles just because I've just clicked on it now, so why not? Okay, projectiles is just like a glorified suvat. Okay, as soon as you see projectiles, the first thing I do is I write suvat down the side of my page. So I write suvat like this for the horizontal, and I write suvat for the vertical. Okay, that's what I do. Yeah, I'm gonna do probability, and I'm gonna do projectiles. Why not? Yeah, let's do it. I'm not doing large data set. No way, no way. You can watch Mr. Bison's video on that. That's really good. That's a really good video he's made on large data set. Don't need any more than that. So just watch that. Okay. What have we got? What have we got? What have we got? Okay. Yes. Suvat. I write that way, and I write that way, and then I write in, because this is always the same. A is 0 in the horizontal, and going up, it's always minus G, which in this case is actually 10, which is a bit tricky. That always throws me. I always forget to check for that. So don't do that in your exam. Check always if they say minus 10 in there. Okay. Okay. Then what are we doing? Okay, so we've got U coming off like this. So that means that we need to find the components in the horizontal and then the component in the vertical. And if the angle is alpha, it means this is U cos alpha and this is U sine alpha. This is what this chatting about. Okay, then we do a triangle for alpha, because we know tan alpha is 3 over 4. And that is 3 over 4. And then we square, and then square root to get 5. Okay, lovely. So what does that tell us? That tells us that sine alpha is 3 over 5, and cos alpha is 4 over 5. So we can use this. The horizontal is U cos alpha, so that is 4 over 5 capital U. And the vertical is U sine alpha, and that's 3 over 5 capital U. Okay, and we don't have much more information other than that, do we? Oh, we do. Yeah, absolutely we do, because we are told that S, we've got all the information that is happening at S, so that means that we are going to examine that particular point at S. And what do we know is happening at S? The displacement in the horizontal is 36, in the vertical is minus 18, okay, because it's gone down 18. So horizontal is going to cross in the positive direction 36, but the vertical is gone down 18, so I'm going to put minus 18 there. Okay. Now, the beautiful thing about suvats is that we can link these two equations together for the vertical and the horizontal, because the time will be the same if we're examining a particular point in space, which we're doing. We're examining S. So I say that's equal to capital T and that's equal to capital T. And that allows us to bring the two equations together. Right, what's the big daddy suvat equation? What's the big dog suvat? If it's going down, why not G positive? Because I have set that the up direction is positive and that to the right direction is positive. So anything happening in a different direction is going to be negative. And G is pulling stuff downwards, so that is why G is negative. There it is. There's that big dog again. S is equal to ut plus a half at squared. So in fact, we're going to use that for both of them. So let me set up with the horizontal. I'll do that in green. 36 is equal to U times capital T. And A is 0, so we don't need a half AT squared. That just goes to 0. And then what about the other one? I'll do that one in red. Minus 18 is equal to U, which is in fact 3/5 of capital U, and then minus a half of A, so that's also plus half of A, and A being negative means we got minus a half of A, which is minus 5, and then we have also the T squared. Perfect. What we're going to do next, guys, how are we going to find U? What we're going to do next? What are we going to do next? What about V? I can tell you about V. V can do one. Don't care about V. V is, yeah, it's not very helpful. Also, massive misconception that I know people make with projectiles is that when something hits the floor, so when you examine this point here, some people say V is equal to 0 there because it's hit the floor. That is not the case. If V was equal to 0 there, then it means that when you jump off a building, you wouldn't hurt yourself. The fact is, when you hit the floor, you hit with a serious amount of velocity, and that is why that's why you hurt yourself when you fall over, basically. So don't make that mistake. V is not known at that particular point. It's definitely not 0 either. Okay, so simultaneous. Exactly. So I'm going to solve for T. Rearranging for T gives me 45 over U. Right, I'm going to try and speed this up because I know it's getting late, guys, and you guys need to get on. And this is going to then go into the red equation. So this gives me 5, and we get, whoops, this should be a T there, shouldn't there? Because it's a half, it's UT plus a half AT squared. Okay, so 45 over U goes in there, and then minus 5 lots of 45 over U squared, like that. Okay, great. Okay, now we can do some simplifying. Minus 18, we can times through by 3/5, and the U's will cancel out, so we just get 27. Here we can square and we can multiply it through by 5 as well. So we get this, and then this all comes out nice and neatly to get U is equal to 15. Are we good with that, guys? Forgot the T, big dog. Yes, sorry about that. I forgot the T. Chucked it in there at the end, though. That's why you always got to go over and check every single line as you go. Sir, please do another stats one. Yes, I'm going to do a probability question. Absolutely, 100%. I will do that. And we've got that now, so let's go on to the next part. And that is to find the speed of the stone at a particular point. Okay, so please post a live after this. I think it's going to get posted anyway, no? Okay. So, I think this is all good. So what we're going to do next is we're going to look at what's the velocity in the horizontal when the stone is 10.8 above sea level. What's the horizontal in what's the velocity in the horizontal? What's the horizontal velocity at any point during the motion? It's the same. It's absolutely the same. So because the horizontal is the same, I know that the horizontal velocity is equal to 4/5 U, like it was right at the start, which is 4/5 times 15, which is 12. Perfect. Now the vertical changes, so we have to do a suvat to find the vertical. Okay, so suvat, like so. We know this is minus 10. We know initially it was sine, which was 3/5 times by U. So this gives me 9. And what is the position of the object if it is 10.8 meters above sea level? So what's the displacement that I'm going to put in for S if it is 10.8 meters above sea level? Yes, Louis. Yes. Is that the same Louis that was in my live sessions on the weekend who was just absolutely smashing it and getting there before everyone? Yes, it is minus 7.2 because it would have gone down to here, so it would have gone down by 7.2, so it would be minus 7.2 is what we need to put in. So minus 7.2. Okay, we need to find the velocity. T can do one, which means we're using v squared is equal to u squared plus 2as. We get v squared is equal to 81, u squared is 9 squared, plus 2, a is minus 10, and s is minus 7.2. So we get v squared is equal to 225. And that's all. All I need is v squared, in fact, because I'm finding the speed. The speed is the magnitude of the velocity. So that means I'm doing the square root of the two components squared. And Vj squared is 225. And Vi squared is 12 squared, which is 144. And that is going to give me 19.2 meters per second. Love that. Love that. Okay. Yeah, we good with that? Yes, hero in there with that, with the correct answer. Love it. Projectiles and ladders goated. Absolutely. Projectiles and ladders are done. Okay. Come on, you hammers. Yeah. Up the irons. Okay. Probability we're going to next. This is where we're going. Yeah, we're going to probability. Guys, I've got to go. I've got to go down here. Didn't see that coming, did you? Okay. Right. This looks horrible. Yes, it does. I've actually clipped off some of the information. It says that D is like bringing drinks to the school party or whatever it is. S is sandwiches. C is chocolate. Okay. Right, let's go. Let's go. Probability S. Okay, what's this, guys? You tell me. Can you explain how S was minus 7.2? I can explain that again because it said that we wanted to inspect the point which was 10.8 above sea level, and we started 18 meters above. So therefore, I would have moved 7.2 downwards to get to 10.8 above sea level. So the displacement was minus 7.2. Okay, the answer to this one is 0 because you cannot be in S without D. So sandwiches is a subset of drinks, which means that you can't have sandwiches without a drink, essentially. So there is no probability of being sandwich without a drink. Okay, lovely. Right, that's part A. Part B, it says that we've got 80 lunch boxes. And how many of these lunch boxes will contain a chocolate bar? Well, we need to find the probability of having a chocolate bar given. Let me read this question a bit better. Actually, sorry, I've got too excited. I wanted to answer it too quickly. 80 students bring in a lunchbox. Given, there's that given, that all 80 lunchboxes contain a sandwich and a drink. Right. So what is given then? What is given is that they contain a sandwich and a drink, like this. Okay. Okay, so this is the probability. Yeah, how do we do, what's this conditional probability then? Conditional probability, what goes on the top line and what goes on the bottom? Because when we do conditional probability, then we have something on the top and something on the bottom. And AV3RM4, very catchy name there, was there first. It's C intersection S and D over the probability of S and D. Love that. Love that. So in fact, on top is the probability of C intersection with S intersection D. And that's all over what's given, which is S intersection D. So let's try and figure this out by drawing it on, colouring it in. So C and S and D. Where's C and S and D? It must be these guys, right? They're the only people that are in S, C and D. And that's over this one, which is S and D, which is all of this. So that to me looks like 0.27 over 0.33 plus 0.27, which is equal to 9 over 20, or 0.45. Yes, good stuff. Okay, lovely. Right, I think we can get rid of most of this now actually, and let's just move on to the final part. I think we can get rid of that. Yeah, why not? Okay. Oh no! Oh no! I didn't answer the question. I didn't answer the question. Because this is an expectation question. Because it says to estimate how many of these 80 lunch boxes will contain a chocolate bar. Well, the chance is 0.45. So I need to multiply that by 80. And that will give me, calculating, 36. Yes, thanks chat. Woohoo! Sussy little fella you are, sir. Thanks, Jake. Okay. Right. Let's go on then, shall we? Let's go on to part C. Okay, part C. Part C, and it says, okay, so we've got loads of information here. I can set up 3 equations, in fact. I've got one bit of information, like that, and I've got one other bit of information, and then what is the final bit of information which is true for all Venn diagram probability questions? So can I leave it as a fraction? You can leave it as a fraction if you want to, but I think the answer was 36, no? So I don't know if we want to leave that as a fraction. They all add up to 1, absolutely, yes. So we've got another one, which is the sum of all the probabilities is equal to 1. So we're going to use these 3 bits of information to solve this 7-mark question. Okay, the first one we'll do is the independence one. Let's start with that. What does that mean if they're independent, guys? What does it mean if they are independent? Why was it 0.7? The last one was 0.7 because it was this area there, because that was the only area which contained a chocolate bar and was given that they contained a sandwich and a drink. So that's why we had 0.27 on top. Okay, good. Yes, that is lovely. Independence means the probability of S times the probability of C is equal to the probability of the intersection of S and C. Right, so let's colour it up then. The probability of S is all of this. So that's 0.6 times the probability of C, which we can see is all of this. So I can write that as 0.27 plus u plus v, and that's equal to the intersection. So what's great about colouring is that you can actually see really clearly where the intersection is there. Where do these two sets meet? What's the value of the intersection there? We need a Euros watch along after this. Yeah, for the Scotland game. What is the intersection there? We can see it nice and clearly. When we shade in Venn diagrams, the intersection is literally the part which is coloured in a different colour. That's like GCSE art right there. Not even GCSE, like Key Stage free art. And it's 0.27. Okay, lovely. Right, we can tidy this up a bit. Divide through by 0.6. And we get this is equal to 0.45. So therefore u plus v is equal to 0.18. And that's as far as we could go with the blue bit of information. So now we're off to find more information, and we're going to do it using the green bit of information, the conditional bit of information. And that is that the probability of D given C is equal to 14 over 15. And that is equal to the probability of the intersection of the two over the probability of what's given. The classic conditional probability equation. Love it. Okay, so we need to find these probabilities. D and C. Where do D and C intersect, guys? Where do D and C intersect? Where do D and C intersect? Okay, got a few different answers here. Not just V. Not just V. D and C intersect right here. Okay, so that is these two together. So that is going to be equal to 0.27 plus V. Okay, lovely. And what else? We need over the probability of C. Well, the probability of C is all of this jazz over here, which is 0.27 plus U plus V. Okay, we're good. We're good. And in fact, we've now got two equations that contain U and V. So that means that we can solve them simultaneously. And I've just spotted here that U plus V is down there, and I know exactly what U plus V is. So I can write 14 over 15 is equal to 0.27 plus V over 0.27 plus 0.18. I've just substituted out that U plus V for 0.18, and it looks like we're good to solve for V now. This is just an equation that only has V in. So we can solve this for V, and we get 0.15. And if we know V, we then know U, because we know they both add to make 0.18. So we can find U. Beautiful. And then the final thing would be to use the yellow bit of information. And that is that when I add them all up, everything is going to equal 1. So I'm going to get that W plus 0.6 is are those two inside S, plus U plus V is equal to 1. I know U plus V is 0.18. And I know 0.78 is equal to 1. So W is equal to 1 minus 0.78. So W is equal to 0.22. Beautiful. Okay, fantastic. Right, I think we're, oh, it says ads running. I skipped those ads. No, we're not doing that. Okay, right, guys, I think we're good. I think that is 8 o'clock, and what we've done, an hour and a half. Wowza. I hope that was helpful, guys. I really do. And it says that I had 1,000 concurrent viewers, which I think is good. Is that good? I don't know. Well, I felt good, and I hope that was really useful for you guys. So, do me a favour. Get me some more subscribers. If I've helped you at all during this exam period, yeah, just like get me like 5 subscribers. Just some random people. Get them to subscribe to Mr. Asprey. Because I want to get to 100k. I want to get to 100k. Yeah? I want to see that subscriber count popping off tonight, because you're getting your mum, your dad, your brother, your uncle, your grandma, and the postman and everyone to subscribe. Yeah? Anyway, I'm only joking, guys. I really appreciate all the support that this Maths A-level community have been giving me. It's been fantastic, and I really hope you're the best. I'll do a reaction video tomorrow, and then that'll be it. I'll say goodbye. But yeah, if you could get me some more subs, then that would be absolutely amazing. Because I always get like a drop off after the exams, and it's really sad. But if you get me 6 subs, then it's going to go up. Anyway, guys, it's been an absolute pleasure. I wish you all the best. See you later, guys. I'm going to end the stream here in time for the footy. Love it. Bye-bye, everyone. Bye-bye.